The next presenter is my dear colleague Tom Ryckeboer. Tom graduated in 1997 as an industrial engineer in Ghent at the university. And afterwards he worked for 14 years for CCB, Belgian grey cement producer, before he became an independent consultant for architectural precast and also worked for Dutch precast companies as well as for a Danish one, right, based in the Netherlands. And since 4 years, we are very happy to have Tom on board of Aalborg Portland, and especially in our white cement business, Aalborg White. So here Tom is since 4 years responsible for the technical sales in Benelux and France, and he's one of the drivers, one of the main drivers of our innovation stream that is mainly dealing with high performance and ultra high performance concrete. So Tom, the floor is yours.
Okay, thank you, Frank. Good afternoon, everybody. First of all, I would like to thank you for your presence. I think it's a success to have, in total, we have 150 participants, not so much here in the room, but then we have got a lot of interest from all over the world. So that is nice to have a good audience and to share the knowledge. So today we'll talk about the concrete of tomorrow, more performance, more durability. So let's say after the speech of Peter, who was more about historical projects and the whole, also more focused on the civil works. We will now focus a bit more on architectural applications, and we call it the new generation of UHPC. I will explain to you what is our vision to take UHPC to a more extended range of applications, and also the durability is playing a big role in that. And that is, of course, about the raw materials that are used. So first, a little explanation of who we are and what we do. Aalborg Portland, we have 5 cement plants all over the world, in the US and Denmark, Egypt, China, and Malaysia, with the capacity of over 3 million tons of cement. 3 million tons of cement looks big, but if you compare it to grey cement production, we are only peanuts. Say on world scale, we are with this these numbers only 1% or less of the total cement production worldwide. But for the white cement, let's say we are world leader in the production and the distribution of white cement. We have a history of 125 years. This is in our plant in Denmark, in Aalborg, where we already have this long history. But from Denmark, we distribute our cement all over the world, present in more than 60 countries. And important for us is also not only to sell the product as a white cement, but also to give a technical support and customer support to be able to the customers to have a value adding on their activity. And we try also to go and code development for new applications, and this whole stream of UHPC in white products is helping us with that. So Aalborg Portland is also part of an Italian group, Cementier Holding, which has operations in 17 countries and more than 3,000 employees. Starting from white cement, we can give some segments of the application of the white cement. Of course, white cement is always very important and aesthetical products. So for the facade, of course, precast facade elements. Then it is also used in paving blocks and then infrastructure works. Then artificial stone, this is also more for cladding of facade. In Asia, we have a lot of GRC, and in Europe, of course, we are also progressing in these techniques and in these projects. But the GRC is standing for glass fiber reinforced concrete. And then the UHPC, of course, that's what we're talking about today, is precast elements, with high strength. And then the dry mix mortars are for us also an important segment. All kind of mortars, reparation mortars, tile adhesives, skin coats are also based on white cement. And last but not least, also for in situ projects, white cement is often used like in these projects in Asia. So just to position where ultra high performance is situated in the whole concrete industry, let's say, we have the primary segments: precast, wet cast. We have paving and masonry products, which we call semi-dry cast, and then the dry mix mortars, ready mix concrete, and special applications. Of course, for ultra high performance, we are talking about a high-end industrial product. It's important also to have the good conditions to guarantee the quality. So UHPC until today is for 99% made in precast conditions with high quality standards, of course. Also because of the aesthetical effects and the aesthetical result we want to achieve, it's in the precast that most of this production is made. So yes, starting from conventional concrete, known by everybody, you know, of course, cement plus aggregates and sand and water, we can achieve different strength classes. But let's say as the European standard is only going up until strength classes C100, 115, means 100 Newton per square millimeter for the cylinder strength and 115 for the cube strength. This is a limit that, yes, since the development of high performance and ultra high performance has been passed. And so the guidelines for the higher strength classes is still in evolution and is also still in negotiation. We can say in France there is already a very good guideline available, standard, where there also a lot specifications about performance and the production are already described. So yes, you can eventually consult this document, which is the most recognized one worldwide. Other countries, Germany, there is still in progress a guideline for UHPC. In Switzerland, we have already also a good recommendation, as told by Peter. Switzerland is also very active in UHPC, but let's say maybe more in the field of overlays and road and bridge reparations. And then also in the US and in China, that is more recently, there is a lot of new standards that are being developed and also for GRC and for UHPC. I will not go too much in detail for these standards, but if you need more info on that, there exists some literature, and we can help you with that to find the good way of the standards. So first, to talk about UHPC, we start with traditional UHPC, because then after that, I would like to take the step to the new generation of UHPC, but the traditional UHPC until today. The parameters that are important is the water-binder ratio, very low, of course, between 0.15 and 0.25. Here we are talking also about a high amount of silica fume, 20 to 20% by the weight of cement. And these kind of mixes are, of course, also characterized by a high packing density. This is important to have this high packing density, of course, to achieve the high compressive strengths between 110 150 MPa, even higher. And also the high ductility and the durability is important. The microstructure has almost, it's so dense that there's almost no external liquids or other products that can go into this matrix because it is very dense. So we are still in the traditional UHPC. Three components, of course, the binder. We have binder contents that are also very high and sometimes more than 50% in weight of the product. And also in traditional binders, superplasticizers are often included in this binder. And then next to the binder, we have the aggregates. In most cases, we are working with fine fractions between 0.5 and 2 millimeters. And then in function of application, the fibers that are added, that can be steel fibers, glass fibers, PP or PVA fibers. But this is meant to give to the material a residual post-cracking strength. So that means once you have a crack in the concrete or the divided cracks in concrete, that the fibers can give the post residual strength and take up even higher flexural strengths than the original concrete material. So focusing now on the binder is one of the components. The binder is, of course, has the cement in it for the hydration reaction, and silica fume is often used as an ultrafine, also reactive powder. And then sometimes, there is also an adding of supplementary cementitious materials like fly ash and calcined clay. And other fillers, inert fillers, are used like quartz flour and limestone. And the superplasticizer is polycarboxylate polymer that is in a dry powder included in this binder. And what I want now to explain, what is our approach with Aalborg Portland, is that we, for durability reasons, we don't add silica fume anymore in our UHPC, because we have seen that silica fume sometimes there are some problems of availability and also the volatility, let's say, price-wise is often a problem. And we believe that a solution to that can be to use metakaolin, which is an argil fraction, together with limestone. And so we developed a new technology called the Future Sand technology, who is based on this replacement of silica fume by metakaolin and limestone. Because that's, we have, after a lot of research, also seen that it gives some benefits. We still see further. The most important ones are the shrinkage, that we can reduce shrinkage even more. And also about flexural strengths, we see that we can obtain some higher performances. So the technology that is behind this is the FutureSense technology. And this is based on 3 key values. It's a green solution because we can reduce clinker content with, we can reduce the CO2 emission through clinker replacement 30%. And of course, it's also sustainable because the products we use are more available, more widely spread. And it's also innovative and validated. Yes, of course, before sending out this technology, a lot of research has been done, and it has been validated by our Research and Quality Center in Aalborg. And this technology is also patented in Europe and in other countries. And it's a part of the LC3 evolution in cement. The LC3 is a limestone calcined clay cement, which gives a good possibility for the clinker reduction. So based on this technology, we have now developed until today 2 premix products that are available on the market, and also a binder product. The first one is Aalborg Extreme Light 120. So it is based on white cement, of course, and it is an all-in solution. So a premix means you only have to add water and you can achieve a self-compacting concrete. It's even a shrinkage reduced mortar. And our strategy also with this product is we only provide the premix, and then we leave the choice to the customer for the tailorization, like what kind of fibers are needed for this application. Is it a structural or a decorative application? And of course also pigments and coatings. This is free to choose for the end customer. So the principle is very easy to use. We have the Aalborg Extreme in bags 25 kilo, or also available in big bags, 1 ton. The water dosage is something that is very fine-tuned, also in the lab. So let's say that the range of water dosage is very narrow, and you have to respect it to be sure that also the performances you want to achieve will be achieved. And so the compressive strength for this product is minimum 120 MPa. And practically, it is also a strange material to mix. You can almost not compare it to a traditional concrete. The consistency is very different. That is because when you start with the dry powder and you start mixing with adding the water, you first see that you have nodules appearing, and these nodules are becoming from a small diameter, a larger diameter, and they come in after 3 minutes approximately in a clay phase, because so the agglomeration of the big nodules becomes very hard to mix at that moment. It is on 30 seconds that it is very hard for the mixer to go through this phase, and then after 5 to 10 minutes you have self-compacting consistency ready to cast. So in fresh state, we can guarantee a flow of 900 millimeters, and also the flow retention 45 minutes. It's in normal conditions. when normal temperatures between 15 and 25 degrees. Of course, if you go higher in temperature, the flow retention will be less. And also going lower is not so good for the flow. And also a very limited air content. And in Aalborg Extreme, we are working with an aggregate of maximum 3 millimeters. Here you can see how it looks like with the Abram cone. So very slowly flow, but achieving 900 millimeters. So the main benefits of these products that are based on the future SEM technology with inclusion of metacolin is firstly the shrinkage. Shrinkage in UHPC, it has a lot of fine fractions. It's really a topic that you have to consider. And we have seen with working with metacolin as fine addition that we can limit the shrinkage at 28 days at around 420 microns per meter, while at 90 days, okay, it's a little higher. But if you compare it to other UHPC mixed designs with silica fume, it's a lot lower. We also did a lot of test of fibers, of course, steel fibers, PVA fibers, and important for us is also the residual flexural strength we can obtain. But of course, we see that we can lift it up even to 13 MPa, 14 MPa. Flexural LOP, that is the limit of proportionality, and then going up for residual strength, that is the the straining behavior. So we have even go higher until 20 MPa, but of course later this afternoon the people from the fibers will go more into detail. And then in hardened states, okay, we can say that compressive strengths at 1 day are above 85 MPa and 28 days, depending on the kind of samples, above 120 or 135 MPa. And then the durability wise, see that also chloride migration and water absorption is very limited. So why to choose UHPC? That is, of course, the main benefit is to reduce the weight. We have seen, for example, at the beginning we had traditional reinforced concrete, then the technology of the pre-stressed concrete. And now let's say that UHPC is giving the material the characteristics that it is becoming near to steel. Thanks to the elasticity modulus, we can reduce 40 to 50% of material use. And that is, of course, if you can reduce the weight, that means also and transportation costs and assembling costs that you can make more profit. Also in wall elements, traditional, yes, you have to take into account also the coverage of the reinforcement steel. In the first step, you can reduce the thickness of the panels, but also the advantage of traditional in relation to traditional concrete is that the coverage of the reinforcement steel, you can reduce it to 10 to 50 millimeters. instead of 40 or 30 or 40 millimeters. So this makes that making slim elements, you only have to take into account for balcony plates, for example, that you have enough with 15 millimeters of coverage. So weight reduction, let's say 40–50%. That means also less CO2 footprint. Yes. So the first product we put into the market was the Aalborg Extreme, but we made the second version of it because we wanted also for decorative applications a matrix that is even more fine than the one for Aalborg Extreme. So there is a difference you can see in the aggregate size. For Aalborg Extreme, we have the T-max of 3, and for the Aalborg XL only maximum 1 millimeter. And also the flow is a bit better, let's say, for Aalborg Extreme XL. It makes it possible to have complex formworks. And then the applications are also a bit different. For the Aalborg XL, is more in combination with PVA or PP fibers, and for decorative application like facade cladding, urban furniture, sunscreens. And the Aalborg Extreme is more for structural elements like balconies, bridges. So that is the reason why we made this division of these two products. So these two products are in fact the first step in our innovation plan for the coming years. All started with the future sand. This is the base, the binder, the cement that is used for these kind of products. Then the Aalborg Extreme and XL are on the market. We have a product on the development for the moment is Aalborg Explore. This is for 3D printing. And then for the new solutions that are launched this year, we launched Aalborg Inbind. And in the next future, Aalborg Ryckeboer will also come shortly. Aalborg Inbind is in fact the binder that is used in Aalborg Extreme and XL, but we want also to launch it as a base product where customers can choose which sands they can add to work also with local products. I think it's an ecological benefit. People can use local products, so you don't have to transport your sand all over Europe. And secondly, yes, the customer, in function of the application he has more liberty to achieve it. And Aalborg Ryckeboer is then also more a premix product, which is suited for overlays. We saw a lot of projects with overlays, bridge overlays. We will also come with a product for that application. So the last product that we are now launching is this. That is named Inbind. So it is also in the range of ultra high performance. It is customizable. You can choose your local aggregates and mixtures. Of course, reliable because the quality control procedure is guaranteed in our and monitored in our research and quality center. And we give to the customer a package of tests, let's say, to help them to make the good mix design they need in function of the application and the performances they need to achieve. Yeah, applications are also more or less the same as for Aalborg Extreme and Aalborg XL. like sunscreen lamels, we have resile panels, and then also flat facade cladding or furniture. Some more figures about compressive strength. So we already achieved after 1 day 75, after 28 days up to 180 MPa. And the flexural strength, let's say we achieved above 20 MPa. And then I can already show you some projects. These are projects mostly based on our premix products. So this one is based on Aalborg Extreme. This is an office building in Reims in France, made by a company Delmar Betsinor in France. And it's the famous architect Rudy Ricciotti, who is, let's say, the pioneer for UHPC and slim architectural design. So there we made something like 6 kilometers of this kind of lamels, but also bended in more than one direction. So the formwork was not so easy. This is a project of Enjoy Concrete for balcony frames. Balcony frames with also very slim design, only thicknesses of 75 millimeters, 85 millimeters at the top. And so these frames are made in one element. So formwork wise and reinforcement wise, not so easy to make, but okay, we succeeded. And then lamels, instead of horizontal lamels, we have also vertical slim sunscreen lamels. This project is Swissport Zaventem, but there is a presentation later which will give more details about it from for the Dale Sea Concrete. This is also lamels for a project in Newport. For Enjoy Concrete also made this bridge project with very slim elements, not only the stairs but also the connecting parts, with only thickness of 85 millimeters. This is a project in France. Panels for a facade from it was 13 meters by 2 meters on 8 centimeter thickness. This is a project in China with panels, facade cladding 1 meter 30 on 3 meter height, only 60 millimeter thick. And these are some projects from Icon, which are made with CRC, compact reinforced composite. And you can see that, of course, the slim design is it is only 6 centimeter thickness on the top, and this can also be applied in balcony frames, balconies. And this project is also from Hycon. It was already shown by Peter. So to make larger spans for these kind of aesthetical bridges. I can say also that these pictures it's about the development of 3D printing. So we work together with the Danish Technological Institute, and these are already some results we could make. And these are some benches who are placed in Times Square in New York, also with 3D printed mortar. So this is my story, let's say. I hope, yes, application-wise, we can make an extension to make it more broad than until today. Yes, hopefully we can have some inspiration. And if you have some questions, of course, can reach us. Okay.
Thank you, Tom. We have one question coming from the online audience. So could you please elaborate on the early age shrinkage of your material and from what time you consider that shrinkage is not solely plastic shrinkage anymore?
Yes, there is a difference between plastic shrinkage and then the early age shrinkage until 28 days. We consider in this case, the figures we have is not in the autogeneous shrinkage, and the plastic phase is not included in that.
Okay.
Why not? It's not used in standards to combine or to accumulate it in the figures. I think the norm is mentioned. So okay, the figures, the standards exist, and we used, of course, the measurement methods that are in the standards.
So that shows that there is something wrong with the standard, because it's the most important figure.
I think autogeneous shrinkage is also important, yes.
And you have to measure it actually from the moment that you are casting, when you want to have a real accurate figure, especially at UHPC. Because there you have the largest shrinkage in the first few hours. So when you cast a mold, you let it hard to bring it to the lab, you start to measure it, it's already wrong.
Yes, I only know it's measured according the standards, and then of course, yes, discussion can indeed be should the standards be
And
changed.
it's very important for prepare because you have balls and other things in it. So that, let's say in the traditional UHPC, you talk about several chrome. So that's already enough to make a crack.
Yeah. Okay, but
Good. I think
I'll ask the professor in Switzerland why it is not in the standard.
yes. Yeah, maybe we should look a bit deeper into that one. That is definitely one item to be improved in the future.
It's a very difficult test. When you do it, you have to take really care that everything is done the right way. Otherwise, you're measuring something what you don't want to measure. So you have to seal it. No evaporation at all is allowed from what you cast. So you need aluminum foil and things like this. Otherwise, you are measuring wrong.
yeah,
Good.
I think
Any more questions?
Just
Yeah.
one about hydration walls. So temperature
yes,
rising
yes,
due to
hydration.
can you elaborate a bit about it?
Yes, of course, because of the high cement dosage, the low water binder ratios, you have higher raise of temperature than in traditional concrete, and also the strength development the first day of the first 3 days is already at the maximum almost of it is going very fast, and also the hydration temperature is going higher. But as you work mostly in more slim elements, the temperature it will rise a little higher maybe than traditional concrete, 50-60 degrees. But that depends also on the formwork.
Good. Then one more hint, Tom, from the audience, from the online audience. In Canada, it seems they have developed annexes for UHPC to the standards. So maybe we should, for completeness, we should add it to our slide with the standards always.
Interesting.
All right. Good.